Hello, ladies and gentlemen, and welcome back. Root Beer here, and we're on question number 4 from our 2010-2011 Alberta math contest. The number of pairs xy of non-negative integers, so 0 or positives, so that 3x plus 2y is 27 is... Okay, so we just need to get the x's and the y's here. That's all that really matters. So one thing you can do, I mean, you can guess and check. Absolutely, but unless you're very organized with your guess and check, it's going to be kind of hard to tell whether or not you've got all of them. And we do want to find all of them, or at least be able to count them all. One thing you could see really quickly, x being 9 and y being 0 would give me 3 times 9 is 27 plus 0. So that's definitely one, and that one is not too hard to find. And so questions like these tend to follow a pattern. Usually you find one solution, and then you find a way to change that solution into the other solutions. Okay? Let me show you what I mean. Suppose I've got a solution. Maybe call it 3a plus 2b to get rid of the x and y variables from the original equation. Okay. Now, if I took some of these b's away, so I've got some b's here, I could, well, no, let's not think of it that way. Let's think of it as I've got a3s and I've got b2s, and I'm adding them all up, and they happen to be 27. So if I got rid of some 2s and turned them into 3s, we could rearrange this. Now, how many 2s can turn into 3s? Well, 2 times 3 is 6, which happens to be 3 times 2. So 2 3s is the same as 3 2s. So if I get rid of 6 here and add 6 here, I haven't really changed the 27. Of course, this 6 I can factor out a 3. And this 6 here I can factor out a 2. Okay. So if AB is a solution, then A plus 2, B minus 3 is a solution. And you can go backwards. You can do A minus 2, B plus 3. Okay? And a little bit of work with greatest common divisors can tell you that that's the best you can do. You know, there are other ways. You can do A plus 4 and then B minus 6, and things like that. But you're not going to get any sort of pairs in between these ones here that differ by a or differ by 2 and 3. So what we can do is we can say, oh, okay, we've got a solution, 9, 0. And what can we do? Well, we could add 2 to the 9 and subtract 3 from the 0. Okay? And you can keep doing that, and all of these will be solutions. But you'll notice they're not solutions that we're asking for because they said they wanted non-negative numbers. So we can go in the other direction. We can subtract 2 from 9 and add 3 to 0. Subtract 2 from 7, add 3 to 3. Okay? And, you know, do a random spot check. 3 times 5 plus 2 times 6, that's 15 plus 12, that's 27. So it's working. 3 and 9, and subtract another 2, you'll get 1 and 12. And then you'll get minus 1 times, and then does it really matter that you'll get 15? No, because we wanted positive solutions. So it turns out that there are just these 5 pairs xy that work. That's it. That's all we're looking for, 5 pairs xy. So that gives us an answer of B. Another way to approach these questions, just while we're talking about them, 3x plus 2y equals 27 is a line. Right? It's a line. If you want to, you can rearrange it to look like y equals mx plus b or something like that. But it's a line that goes like this. And what we found is that 9 zeros on that point is on this line. Okay? But what they're asking for with integer values for x and y is they're just asking what lattice points, so points that have integer coefficients, what lattice points are on this line. And so that's what we're really doing. We're finding those lattice points, specifically the ones in the first quadrant, because we wanted non-negative x's and y's. Okay? So that's another way to visualize this problem. Does it give us any new insights? Not especially. But it's another approach, and it's always a good idea to have different approaches. Have techniques that work, have different ways to visualize in case the question was a little different, and there we go. But either way, we get ourselves an answer of B. Okay, so up next, question number 5. Give it a try before joining me for that in the following video.